Hello students, welcome back into the another session of CS07 data structure using programming in C. In our previous lecture we have completed with all the sorting techniques as per the Saurashtra University prescribed syllabus. Now it's time to go for the various searching technique. So in data structure, as per the syllabus of Saurashtra University, we need to discuss three searching technique, that is index search, sequential search and binary search. But before discussing each individually, first we need to clear the concept of search itself. What does a search means? Yes, search is also called as one type of finding technique. Generally, in array, it might possible that it contains a very big bunch of data, and from this big bunch of data, suppose we wish to find out a specific element, then that technique is called as a searching technique. Say for example, suppose we have the numbers like this, and from this entered entire number, suppose we wish to find out any of the number, then by comparing this key element, that means the number which we want to search is called as key element. Whatever the key element which we want to search from the entire list, for that we need to compare the key element with all the elements of array. That means we are comparing 8 with 5. The search is unsuccessful. Move on. Compare 8 with 2. Search is unsuccessful. Move on. Compare 8 with 1. Search is unsuccessful. Move on. Compare 8 with 0. Search is unsuccessful. Move on. Compare 8 with 6. Again the search is unsuccessful. Move on. Compare 8 with 8 itself, where the search becomes successful. But all these elements should be stored over the specific locations. That means 5 is stored over the location number 0, 2 is stored over the location number 1, 1 is stored over the location number 2, 0 is stored over the location number 3, 6 is stored over the location number 4, 8 is stored over the location number 5, 7 is stored over the location number 6, 10 is stored over the location number 7, and 20 is stored over the location number 8. So the key element called 8 is founded positive. That means search is successful over the location number 5. So based on this, various searching technique is introduced into the concept of data structure. So for the same, theory is written over here. In a computer system, often they are storing the large amount of data which individual record must be retrieved according to the some search criteria. Thus, The efficient storage of data to facilitate the fast searching is an important issue. So in this section, we will discuss about the various search operations. Searching for the data is one of the fundamental field into the computing. Often the difference between the fast program and the slow one is the use of good algorithm for the data set. Due to this, various searching technique has been introduced as per the syllabus, that is called as index search, sequential search and binary search. From these three, binary search is very important as per the university examination. This sequential search is also called as linear search also. That means, suppose we are comparing a key element with all the element which is stored inside the one-dimensional array and on which the location the search became successful, that technique is called as index search. Instead of retrieving the location of the searched successful element, we are retrieving itself value onto the screen. That means, suppose we are not considering the address of element on which it is stored. Instead of that, we are just considering the value itself. That is called as sequential search or linear search. Into the binary search, first what we have to do, we have to sort the record from smallest to highest. That means it should be converted in this format. All the unsorted numbers should be converted into the sorted one, and then by comparing the element with each number which is stored inside the one-dimensional array, the search became successful. That is called as binary search. So this was the small part of various searching technique as far as the theory is concerned. We need to discuss their algorithm as well as the program. So let's discuss algorithm number 1. So algorithm number 1 is related with linear search. So algorithm for the linear search is like this, where it consists of total 5 steps. Let me rearrange properly. These are the 5 steps of linear search, where 3 variables are used for linear search. First is the L, represents the list of element. N represents the number of elements into the list. That means into the L, whatever the number is there is represented by N, and the element represents the element which we want to search into the list of N numbers. That means, suppose we are entering any unsorted numbers like this, then this is called as list. As far as our algorithm is concerned, it is called as L. Then this 5, 2, 0, 1 and 3 individually is called as N. And suppose from this list I want to search for 0, then it is called as element. That means variable number 3. Now what is step number 1? Step number 1 is initializing the two variables, that is k is equals to 0 and flag is equals to 1. Then step number 2 is repeat step number 3 for all the numbers which is stored inside the list. During the repetition, it checks whether the number is equals to the element which we want to search or not. That means it compares this 5 with 0, whether these two are same or not. If it is not same, then move on. It compares 2 with 0, search becomes unsuccessful. Then again it compares this third element called 0 with itself, 0, search becomes successful. So this is step number 3. Whenever the search becomes successful, automatically it will set the flag equals to 0 and shows the output successful element found at the particular location. If the element which we have entered is not the part of entire list, as per this example is concerned, suppose I wish to search for 7 which is nowhere available into the entire list. In this situation, my step number 4 get executed, where it shows the message that search is unsuccessful and program get exit. Now let's see the program for linear search. So the program for the linear search is like this. Let me compile and check the program first. Let's compile it. As you can see that there are no syntactical errors are that. Let's execute it. Enter 10 values into the array. Fine, we are entering any 10 values like 3, 2, 9, 0, 1, 4, 6, 8, 9 already I have entered, 7, then 0, 1, 2, 3, 4, 5, 5 is left, so let's enter 5. Now once you enter any 10 numbers, as you can see onto the screen, I have entered 10 unshort as you can see onto the screen, I have entered 10 unsorted numbers. Then I am entering the number which I want to search. Suppose I want to search for 4. Enter 4. It gives the message search is successful, element found at location 5 and the value is 4. Let's see whether 4 is on location number 5 or not. So this 3 is on location 0, 2 is on 1, 9 is on 2, 0 is on 3, 1 is on 4 and 4 itself is on a location number 5. So this program technically gives a correct output onto the screen. So let's see what happens if we wish to search the specific record which is not the entire inner list. So again I am entering the 10 values. And then I want to search for record number called 20 from this entire list called 4, 2, 0, 1, 9, 8, 3, 5, 6 and 7. There is no availability of 20. What it returns? search is unsuccessful because 20 is not founded into the entire list. So let's see how this particular program works. So for that I am opening this code into the notepad for better visibility. This is the code. What I have done first, first note down the definition of the program, that is write a program to perform linear search. Very short. Write a program to perform linear search. Then there is a declaration of two necessary library function. Almost in our all previous program we go for the UDF, so even in this program I have used UDF. The name of UDF is linear search. The function type which I have used is function with argument without return value. As an argument I am passing 3 parametric value, that is list. Let's see the algorithm. That means this L is the list. The same thing I have passed over here. This is list. Then the numbers, that is N, my second. Then I have passed element which I want to search, that is third one called element. Now actual implementation of the program starts from over here. So for that, before the function call there is a void main statement in which I am declaring 4 local variables, that is I, j, number, and one array of size 10. You can decrease it, no problem, depends on you. Then there is a CLR SCR, one message which indicates the user to enter any 10 values into the single dimensional array. There is a one for loop which repeats from 0 to 9th location, and it read various 10 values and stored inside the one dimensional array called array of I. Once all the elements gets stored inside the one dimensional array or into the list, it asks for the element which we want to search. Whatever the element we want to search stores inside the variable called number. Then there is a function call where the number which we want to search is passed, total size of the array is passed, and the list is passed into the function initialization. Into the function initialization, the element which we want to search stores inside the element, size is stored inside the n, and all the numbers is going to be stored inside the list. Then there is an initialization, or we can say the step number 1 as per the algorithm of our program, that is k is equals to 1 and flag is equals to 1. So here I have initialized integer k and flag is equals to 0. For I is equals to 0, I less than n, I plus plus. It's a loop which is going to be repeated for all the elements which is stored inside the one dimensional array. During this repetition, it checks all the element of list with the element which we want to search. If both found true, that means this, suppose I want to search 0, then what does it mean? It compares 5 with 0. For this selected line, or we can say this decision making statement becomes false. It repeats again, it compares 2 with 0, this selected line of code or decision making statement becomes false. Then it compares this 0 with element called 0 at that particular time. This decision making statement becomes true. It displays the message onto the screen: search is successful, element found at %d location, that is the location of array, and even it prints the element which we want to search. This is optional. Suppose you don't want to print the element which is already searched, then just remove this particular variable from the printf statement and flag becomes 1. Till that, in during repetition of this entire for loop, if flag becomes 0 only, then it shows what? Search is unsuccessful. That means suppose we are searching for 20 from this entire list which is not there, the flag becomes 0 itself and it shows the message search is unsuccessful. So in this way linear search will work. So I hope all of you got the idea about that how linear search work. Just pause the video and note down. Just pause the video and note down the program by writing the definition, that write a program to perform the linear search. That means pause the video and write down this selected line of code. Again pause the video and write down the remaining line of code. This program is very simple. Even it can be asked into the university examination. I hope all of you have noted down this program of linear search. Let's move on. Next, we are discussing about the technique called binary search. Binary search is also very important as far as the examination point of view is concerned. Let me arrange it properly as I am taking it from my Word file. As you can see onto the screen, this particular algorithm is made up of 6 various steps, where the name of UDF is binary search and we are passing 3 different arguments as a parametric value, where L is the list of element, N is the number of elements in the list, and element itself which we want to search using the binary search technique. So it is similar like our linear search. These statements are similar like a linear search that we have already seen. Now step number 1 is what? Initialize low is equals to 0, high is equals to n minus 1. That means low means what? The first element of unsorted list, and high means last element of unsorted list, and flag is equals to 1. It's a temporary variable. Flag, don't get confused about the word called flag. Flag means a one temporary variable which can be changed during the execution of program. Step number 2 is one loop which repeats the step number 4 while low is less than equals to high. That means for every smallest value of the list, it repeats step number 4. But before that, it finds out the middle element by firing the equation called low plus high divided by 2. Over here, I would like to give a one idea. This equation we have already used into the sorting technique which is called as quick sort. So in binary search, before searching the data, we need to sort the data, and we are sorting the data using quick sort. So step number 4, we'll check the element whether it is less than the middle element. That means the search element should be on left hand side or should be on right hand side. For searching the particular element either on left side or either on right side, this particular decision making statement will work. For left side, it decrease the value by 1, and for right side, it increase the value by 1 for low as well as for high. If during this the element is founded into the list, then it gives the message that search is successful and program gets terminated. During the every repetition, none of the value get founded, then at last it gives the message that search is unsuccessful and program get exit. No doubt this portion is little bit difficult to digest, but it will be very easy whenever we'll see the program. So let's visit the program without wasting more time. This was the code of binary search. Fine. Let's compile this code. Let's run the code, enter any 10 values. And enter the value which we want to search. Sorry, something goes wrong. Let me check it. Let's reduce up to the 5 elements only. Fine, it's working. Search is successful, found at location 3. So let's check whether the uh, 9 is on location number 3 or not. 0, 1, 2. It's on location number 2, not on 3. 2 is on location 0, 0 is on location 1, and 9 is on location number 2. What's wrong? Let's rerun it again. 2, 0, 0, 1, 0, 1, 2. Last one is 4. Suppose I want to search for 9. Found at location 3. 0, 1, 2, 3. Now it's perfect. Let's rerun this code with some another value for the cross verification purpose. And I want to search the value called 8. So 8 is on location number 4. 0, 1, 2, 3, 4. Fine. 6 on 0, 0 and 1, 1 on 2, 7 on 2, 3, and 8 on 4. So it's perfect now. Let's see this particular program over the notepad for better visibility. This is the code. What I have done first, after writing the necessary library function and UDF declaration with element, total numbers and the list, there is a main statement where I have declared 4 variables like I, number, j, and list of array of 10, but replace this with 5 because I have changed the scenario. Then there is a CLR printf, enter 5 values in array. Fine. For I is equals to 0, I less than 5, I plus plus, it accept different 5 values in one dimensional array. Then it will accept the number which we want to search and store inside the number. This program is similar up to this selected line, just like a linear search. Then there is a function called of binary search where it pass all the numbers, the size, and all the elements, and it stores inside the variable called this number, that the number which we want to store in element, size is stored inside the n, and all the values are stored inside the list. Now actual implementation as per the algorithm starts over here. First it initialize high, low, mid, and flag equals to 0 variable, where high is equals to n minus 1. What is n? N means the total number of elements, that is 5. So 5 minus 1 becomes 4. Let's take one example over here. These are the total 5 elements. So high becomes n minus 1, where n is equals to 5. That means these 5 elements. So if we perform this functionality, then high becomes 4. That means the position number 4, 0, 1, 2, 3, and 4. So as per this example, high becomes 3. This high becomes 3. Low is equals to 0. That means the position number 1. That means low becomes 5. This is 0. Then mid equals to low plus high divided by 2. That means 5 plus 3 divided by 2. 5 plus 3 divided by 2. 5 plus 3 is equal to 5 plus 3 is equals to 6, 7, 8. 8 divided by 2 means 4. 4 means 0, 1, 2, 3, and 4. This 3 becomes mid. So, mid is equals to 3 as per this particular logic. Now, there is a one looping control structure, and as per our algorithm, it is step number 3. It checks all the element on left hand side of the list, and during this it increase the value of middle plus 1 if the searched element is not founded on left hand side. It search for the element on right hand side, but during the right hand side it increase the value of low. On left hand side it increase the value of high, and on right hand side it increase the value of low. Whenever the elements get found into the entire list, it gives the message that search is successful, and it prints the location. Every time it changes the middle element for checking the another value, but during the every repetition, if flag becomes 0 only, then the message comes onto the screen that search is unsuccessful. That means from this list, suppose we are searching for 20 which is not there in the list, at that particular time this flag becomes 0 only, and it gives the message that search is unsuccessful. So, just pause the video and write down the program. Definition is very simple. Write a program to perform binary search. So, I request all the students just to pause the video and write down this selected line of code. Again, just pause the video and write down the remaining line of code. I request all the students just write down every line properly, so we will get a very less problem while you are executing all this program at your home. I hope all of you have written this program. Just test yourself at your home. In our next lecture, that means all the sorting and searching techniques get over as per the syllabus over right now. In our next lecture, we'll skip the portion of graph yet, because we'll take this concept of graph with a tree, right? That means with unit number 5. In next lecture, we are going to start with unit number 3, which contains 2 subsection: introduction to data structure, this is actually the theory, and elementary data structure, where it contains the concept of stack and queue, which is very, very important as per the university examination. We'll fastly complete this theoretical section that is called as introduction to data structure, because it contains very less theoretical discussion, and then we'll give our proper attention to one of the main part of this entire subject, that is called as stack, and then obviously with queue. So, till that, thank you very much students for listening me, and have a nice day.